Thank you everyone for joining us today for the webinar on how AI makes DDoS more dangerous and what you can do about it. My name is Amit Morrison. I'm VP of Services here at MazeBolt. Joining me today is my colleague Eyal Rahimi, VP of Engineering at MazeBolt. Eyal is expert in cybersecurity, networking, and development with a lot of experience around cybersecurity in the security space. Thank you for joining us, Eyal.
Thank you, Amit. I'm very happy to be here.
Before we begin, a couple of housekeeping items. If you have any kind of questions during the webinar, please use the Q&A section, and we will try to address all the questions at the end of the webinar in the Q&A section. We will try to have time and answer all the questions. Obviously, if we will not be able to, we can follow up with an email to anyone who has specific questions. If you want to connect with us, either with me or Eyal, you can contact us on LinkedIn or find us on the MazeBolt website and contact us directly for any conversation or follow-up question. So let's start and basically understand why we are here. Right? So Eyal, we all know about the growth in DDoS attacks over the years. What's your take on that growth that we've seen?
Yes, so we do see an increase of 10 to 30% year on year in the number of DDoS attacks. But I think the more fascinating number is the fact that we see a huge increase of 53% in the number of damaging DDoS attacks. A part of that, there is two other facts that are pretty interesting. We see the volume and magnitude of DDoS attacks also rising by 56%. And we see a huge increase, a surge in the layer 7, the application layer attacks, HTTP, HTTPS attacks of 550% compared to 2023.
So I think the main takeaway here is while we see a very steady increase actually of volume of attacks and number of attacks, but the damaging attack increase is even at higher percentage, meaning that the attacks are becoming more sophisticated and actually manage to penetrate the DDoS defenses.
Yeah.
So DDoS attacks have come a long way since the early days. You know, how did they evolve? What have we seen in the last few years?
Yes, DDoS attacks started more as a volumetric attacks. They aimed at saturating bandwidth. And then we saw botnets emerge, allowing the attackers to have more coordinated attacks. And after that, we saw new techniques implemented, amplification and reflection techniques that allow the hacker to use much more traffic with less resources. Apart from that, we also saw carpet bombing, meaning you can launch an attack. The hacker can launch an attack not on a single target, but maybe on a range of IPs, making a bigger impact on the targets. After that, the next phase was, I think it all became and started because of the IoT devices. So we all have our own smart home devices, like cameras, smart switches, and etc. And those by default are very vulnerable to attacks, for hacks. And they have been used. One of the famous botnets, for example, to use those vulnerabilities was the Mirai botnet, which allowed hackers to break the 1 terabit % of a volumetric attack, and they reach much more than that in a lot of variants of Mirai botnets. They still exist until today. From that, we saw actually what correlates to the previous slide. We saw that 550% increase, according to Radware, about more layer 7 application layer attacks. So we do see more sophisticated attacks on layer 7, and they are more successful. I think this is currently the stage that we are now getting from this phase to the next phase, which we call AI-enhanced attacks, which we're gonna discuss further on.
Right. So we're moving. We are now at the age of AI, right? So let's shift our focus to AI. How AI is being used to enhance DDoS attacks now?
Yeah, so it's used in many ways. So those 6 specific ways are just part of that. I'll go over them quickly, and I will share with you some experiment I've made, pretty quick and short experiment that I've made. So AI can help us analyze a lot of data about the target. Let's look now in the hacker eyes, okay? So the hacker can actually gain a lot of data that he can put in those AI engines and get a lot of data of vulnerabilities, where to attack. He can also find a way of finding the right attack fit into the right target. He can have better attack orchestration and also botnet management using AI to boost those to much more efficient ways. He can shift the way it behaves and change strategies in real time. But I will go into more depth. I will give you just one experiment that I've made. I used one of the AI engines, and I tried to make a little experiment. So I took MazeBolt, for example, as the target, and I told the AI engine, let's try and test. I want to test that MazeBolt is protected to DDoS attacks. Please find me the right attack, the right service to target. So it analyzed and it gave me a couple of services. Once I got the services, I asked it, what would be a suitable attack to have a damaging attack on those services? So it shared an interesting information that actually correlates to our data that we have. We have at MazeBolt we run around 100,000 simulations a year. And the data we got from vulnerability is actually pretty accurate to what the same AI has said. So at this moment, I had very quickly a vulnerable target, a fitting vector to attack vector to run on that vulnerable target. The hacker would need now a botnet. That's the next phase. So now I started asking the engine, share with me some vulnerabilities that I can use in order to get a hold of devices, something that I can control in order to launch my attacks. So that was pretty easy. The next phase for me was, okay, how can I manage all of that? I just requested a botnet management code. I got actually a pretty good code. So I was missing still the attack. I asked for a specific attack code, which is easy to find across the web. Obviously, the AI found it. And I tried to play with it a bit. I asked him, can you improve that attack? Is there anything you would improve in order to better mimic user legitimate traffic? And I've got some nice suggestions. So this is just a very short experiment showing you how much easy it is to utilize AI in order to be more successful in those damaging attacks. And I think in the last 2 parts of behavior adaptation and strategy modification, we'll discuss later on.
Very interesting. I really like to seeing some of the data from this experiment. Obviously, this is not something that we want everyone to try at home, but it's very interesting what you can get now with the existing AI engines. So we prepared a poll for you guys. If you can please bring that up.
Sure. Okay. So the question here is, which AI-driven DDoS attack technique has the biggest impact?
We would really like to see your input. Right.
Choose a type of attack vector for a specific target. Option 2, automated attack optimization. Option 3, improve an attack to better mimic legitimate user behavior. Or option 4, do not know.
Very interesting. So we see a nice split. Obviously, there are no right answers here, but I think that using AI to generate code has been one of the biggest uses in tech right now. We see a lot of conversations about AI replacing developers. So to some extent, it can happen, but I think it's very understandable that attacker would take existing attacks and try to improve them using AI, and we know that it's already happening. So it's very, very interesting to see that what people think is actually what we see in reality. Any comment from you, Eyal?
Yes, I think all possibilities are good. There is a lot of them, and we're gonna discuss some of them. Yeah. So
we've seen the methods that can be used. What are we seeing that is actually being used? Like what do you see now in the field out of all of these methods that we can recognize that it's actually happening?
yes, so all of those answers that you see here are all we've seen all of them in use. Okay, so we have three that I've chosen specifically, but there is many more. I think the most important one, those are the most important ones for my experience. And I will explain. Okay, so target vulnerability scanning means I'm using AI. I'm maybe probing. I'm again looking in the hacker eyes. I'm probing maybe my targets, my possible targets, finding the right vulnerability to attack. Okay, once I find the right target to attack with the right vector to attack, and I probe all of that, my chances of running a successful attack are much higher. So that's why this is the first one I've chosen. The second one I've chosen, adaptive traffic generation. I think that the more that hackers will be able to make those attacks seem like legitimate users, maybe change the patterns, not have the same pattern, and behave in a more humane way, more normal way, it will make a big headache for the mitigation providers. Apart from that, think about the next generation, which actually some of it exists right now. Think about AI allowing hackers to basically pass challenges. So that's going to make a huge impact on the attack successful rate. And the third one, automated attack optimization, basically can utilize the first two and others. So I can probe actually what I'm doing. I can understand, actually check if I'm running an attack. I want to see if it's working. Am I getting cached? Am I getting blocked? And if it's not working, I can choose another path that can be a different attack, a different vulnerability, and maybe a different rate, different distribution. The hacker can learn a lot from it and actually make it automatic in a way that basically it try to find the right point to penetrate the defenses until it's successful. So with all of those three combined, it's gonna be challenging for the protections.
Yeah, 100% agree. Actually, that reminds me that not long ago, I had a conversation with a customer who basically told me that they recognize that they are being probed. They received very unusual traffic from a suspicious source across many of their services, and basically trying to analyze all the traffic that they got from these sources. They basically realized that they are being probed. And it kind of exactly ties into both the first and the third actions here. So they were probed. The attackers was looking for weak spots and basically to find ways to attack and penetrate the DDoS defenses even before launching the real attack. So we already know that attackers are conserving their resources for the real attack and basically trying to understand what is the best attack point into an organization, what service to attack, what kind of attacks to use. So we actually see that use in practice already these days. So we have a second and last poll, if you can bring that up. And, we're talking about attack points. So how big is that attack surface, right?
Yeah, what is a typical
go ahead.
DDoS attack surface size for an average enterprise? Option 1, less than 100. Option 2, between 100 and 10,000. Option 3, between 10,001 and 50,000. Or option 4, between 50,001 and 1 million.
Give it 30 more seconds. Okay. Okay, very interesting. So we have a very knowledgeable crowd here, and I'll basically explain what I mean in our almost next slide. So most of you think that it's between 50,000 to 1 million, and we'll explain. But before we go to the explanation, we did another kind of an exercise. We asked the new god of the internet, ChatGPT, what does it think about the attack surface? So basically, the answer is with hundreds, thousands of IPs, FQDN services, obviously multiplied by different attack surfaces. All of those services can be attacked on layer 3, on layer 4, on layer 7, all combined in different hybrid environments, if it's an on-prem, on cloud, and so forth. So I wanted to go ahead and explain what is an attack surface. When we talk about an attacker, a sophisticated attacker using AI tools to understand what are the easiest or most vulnerable entry point into the organization, when we talk about all of these attack surface that is scanning, that is probing, is trying to understand what are we actually talking about? What is that? So basically, an attack surface is all of your online services. It may be a website, it may be an API, a DNS server, email server, any kind of service that is online that is accessible or not necessarily accessible to the public. Obviously, you have VPNs and you have other secured connections that are not supposed to be accessible to the public, but are online. So all of these can be actually attacked. And then when you approach those, you can attack them based on the service that they are running. You can attack the service on layer 7. You can attack on layer 4, on layer 3. You can attack a service, and this is not usually thought of. If you have one service, you can still attack this same service with a different layer 7 attack of another service. So the fact that if you're running an HTTP or a DNS service does not mean that you cannot attack it on a different level of a layer 7 attack. And then you have the attack vectors themselves. Out there, we know there are hundreds of different types of attack vectors, types of attack. You can be attacked with a SYN flood, with any kind of HTTP flood, more sophisticated HTTP flood, slow loris, and so forth. So any one of those services can be attacked with any one of those attacks. When you actually multiply it and understand that all of your services can be attacked on many different ports with many different types of attacks, creates your entire DDoS attack surface. And when an attacker, a sophisticated attacker using tools, sophisticated tools using AI, is probing all of those services on all of those ports with all of those different attack vectors on different OCI layers, basically they are bound to find something. Right? So they now don't need to try and attack you to actually understand if you can go down, use their own tools to understand where they need or want to attack, and basically penetrate your defenses on their first try, right, or the first, second try, right? So the fact that they are able to understand where they need to direct their traffic is very, very concerning of what we see lately. And basically, we want to understand how we can protect against those type of attacks. So how do we do that? Let's move on. So basically today, in order to combat and understand ourselves, what is our own attack surface? What is going on in our network? How can we know which of those attacks might penetrate our defenses? What will penetrate our CDNs? What might penetrate our scrubbing center? If we have multi-layers of defenses, a CDN, a scrubbing center, some kind of on-premise device, a WAF. Obviously, if you penetrate one, you're not necessarily penetrate the other, while there are attacks that will completely bypass different attacks. If you have a CDN and you attack on a layer 4 type of attack, you may completely bypass some of those defenses. So we really need to understand what of those defenses are penetrable and what of those defenses we should go ahead and understand what we need to fix there. So how do you do that? Basically now, these days we know that there are solutions such as red team testing. So for instance, if you want to test today your defenses, you would order a red team test, schedule 2 or 3 hours of a test. Usually you would want to run it during a time that there's not a high traffic. Most of your customers are not using your service, if that even an option. Obviously, there are services where it's very difficult to find a time that no one is using the service. But let's assume that you did find one. You invite your teams, your SOC team, your response team, your networking and security teams at 2 a.m. in the morning. You run this test for 2 hours. In the span of 2 or 3 hours, you can run maybe 10 tests, maybe 15, 20 tops. And basically you get a result for one or 2 or 3 different services that were attacked with 10 or 5 different types of attacks. And basically that's all the information you have. But understanding the size of the attack surface, that's basically a drop in the ocean. You have very little information about a huge attack surface. So what's the next stage? We see that the attackers are getting more and more sophisticated. How do we solve it on the defense side? In order to solve it, we need to basically get visibility into the entire attack surface. What's penetrating our CDN or our scrubbing center? To do that, we have a new way of doing things, which is called non-disruptive DDoS testing. In a non-disruptive DDoS testing, you basically can run tests against your entire attack surface during work hours, any time of the day, even in peak hours of usage of your services. And during that time, run simulation that simulates DDoS traffic against your system without noticing anything. That's basically the idea of DDoS, non-disruptive DDoS testing. What can you achieve with that? Basically, once you run non-disruptive DDoS testing, you get a plethora of results. Basically, you scope what you want to test. I want to test these 100 IPs against these types of attacks, get results. With those results, you identify the vulnerabilities. This type of attacks penetrated these defenses, and this other attack penetrated other type of defenses. Remediate those vulnerabilities, basically go to your vendor, listen, these type of attacks can penetrate your system, and this other attack can penetrate a different type of system. configure those systems, change the configuration, change the policy, adjust the policy. And then once you do that, you can validate that those changes indeed block the attack. Now, in some cases, the vendor may say or think that the change they made is going to block this attack, but not in all cases this is true, right? You can validate it for, oh, this attack is still penetrating the defense. We need to make another change. We need to make another adjustment. When this is done, you can validate again. Since this is non-disruptive, you can do it at any time, right? So you're not limited to 2 hours in the middle of the night. Validate that indeed those changes fix the issue, and then move on to another section of your network, to another area, or another type of mitigation that you want to test. So using this method, based on non-disruptive DDoS testing, basically you can go ahead and be a step ahead of the attackers. Basically understand where the vulnerabilities are, fix them, and basically keep, how we say, your attack surface green. Everything will be automatically blocked, and you will not have to worry about attackers probing you and finding vulnerabilities, because you've done that already beforehand and fixed all of those vulnerabilities with the assistance of your mitigation vendor. So this is, we don't have a lot of time. We just left with 3 minutes. So let's see if we can get to one of the questions.
Amit, we received this question from the audience. How do you see DDoS protections evolving?
So basically, I think that once you implement this type of non-disruptive DDoS testing, I think the next stage is to automate also the defenses, right? Where in this stage, if we can understand and have the data of all the penetrable points or the vulnerable points in your defenses, why not take it a step further and notify your vendor automatically, listen, this attack on this IP, this type of attack on this IP will penetrate the defense, adjust the configuration accordingly. So I think once you have this type of data, and basically you can get this data on a regular basis and run those tests, there is nothing preventing you for creating an automated system notifying the vendor, listen, this is penetrates, let's make a configuration change. So I think this is definitely the next stage. If you can now automate the testing, the next stage would be also automating the fixing. Okay? So definitely, I think this is the step forward. I wanted to talk about another points that I saw in the conversation, that the general increase in DDoS attacks is equal the growth of the internet. So I'm assuming that's true. I don't know really. I've never gone into recently, at least, into the growth of the internet, but I'm not sure that the growth of the internet is equal the growth in services in the internet. It might be true, but it's at least showing us that the growth is there. The fact that the internet is growing does not mean that the victims are growing, because as we see it right now, the victims of DDoS attacks are the same financial institutions, the same governments, the same infrastructures. So the fact that and I don't want to name names, but we know that even if the internet itself is growing, it only shows us that the pool of attackers is growing and not necessarily the pool of victims, because the same very familiar names in banking and the same governments and the same infrastructure kind of organizations are keep on getting attacks, right? So we're really out of times. We have some other questions. We will try to follow up at least in an email, and answer all of those questions. And again, you're all invited to reach out to me, to reach out to Eyal, discuss all of these topics, and we're happy to answer everybody's questions. So thank you for joining, and we'll see you on the next one. Thank you, everyone.
Thank you. Bye-bye.
Bye, everyone.